Okay, so the next thing we're going to talk about is power. And power is the rate at which work is done, and it's measured in watts. Since power is a rate, um, it can be fast or slow, and so time um, is involved. And then just as an aside, like for your house, you may see that you have like power in your house and stuff like that, and maybe your electricity bill is in kilowatts. Watts are pretty tiny, so we measure our power, like the power you see at your house is in kilowatts. And this is your formula. Power equals work divided by time. And since it's one of these type of formulas, you can put it in the triangle, which I love. And then we will do this one. And this one is kind of give you a little bit of work example and then a little bit of power example too, because it's a two-stepper. Okay. So in this one, we have an electric motor lifting an elevator. We are all about elevators tonight. 9 meters. So our distance is 9 meters, and it takes 15 seconds to move that 9 meters. And it's exerting an upward force of 1.2 times 10 to the 4 newtons. And so we want to know what power does the motor produce in kilowatts. Okay. And they say kilowatts here. So if this is like a multiple choice question or something, all of your answers are obviously going to be in kilowatts. But if it was like a short answer question on your test and they specifically told you they wanted it in kilowatts, you would have to put the answer in kilowatts in order to get it right. Now, if they just said what power does the motor produce and the question ended there, then you could put in kilowatts, you could put it on watts, you could put it in micro. I don't even know if microwatts is a thing, but you could put it in microwatts. You can do whatever you want. But since they're specifying kilowatts, you've got to do kilowatts. Okay. So our first step is work is equal to force times distance. And we have to find the work because our power formula, remember, is work divided by time. And we don't have any work yet. So we've got to do our work and then we can do our power. Okay. So we have our force and we have our distance. So we can do 1.2 times 10 to the fourth times 9. And that gave me, I always do this. It's like I get too excited to write the 8 and make a teeny tiny 0. We get 108,000 joules. And now that we've got that, now we can, solve for our power, which is work divided by time. So then we can take that 108,000 and we can divide that by our time, which was 15 seconds. And we got 7,200 watts. And then we need to convert this to kilowatts because they told us they want it in watts. So we have our kilowatts. So we have 1,000 watts in 1 kilowatt. So it's going to divide by 100 or 1,000. So we'd get like 7.2. This is one math that I did not do in my head or ahead of time. I think it's 7.2, but I'm going to make sure. I told you I'm bad at math. Okay, 7.2. And your power is going to be in kilowatts. Okay. And that is the last problem I have for you for, wow, 1 minute left. We made it. For the Physics B folks. Like I said, I really want to go through those conservation of energy stuff because I think that's kind of difficult personally, just because the formulas are really long and you've got to know, like, if it's stopped, it's going to have 0 velocity and if, that kind of thing. And then I wanted to go through one of these. It was like a two-stepper because sometimes students will see this and they'll go, oh gosh, I don't see any work. What am I supposed to do? I'm stuck. And it's just because they want you to find the work and then do the power.